If you were in Quebec in January of 1998, you remember the sound. It wasn't the howling wind you'd expect from a blizzard. It was the sound of snapping wood. It was the sound of million-year-old trees shattering like glass rods under a weight they could no longer bear. It was the terrifying metallic groan of steel pylons, massive structures designed to outlast us all, crumpling like wet cardboard. This was the North American ice storm of 1998. In the history books, they call it a meteorological anomaly, but to the people who lived through it, it felt like the end of the world. For days, freezing rain fell relentlessly from the sky. It didn't look like much at first, but it accumulated with a deadly persistence. It coated the province of Quebec in layers of heavy, clear ice. Then the landscape was transformed into something hauntingly beautiful and utterly destructive. A glittering, crystalline ruin, and in the middle of this frozen devastation, the lights went out. We aren't talking about a flicker. We are talking about the collapse of the Hydro-Quebec grid, the electrical backbone of the province. This was the triangle of darkness. And deep inside that triangle, on the south shore of Montreal, the municipality of Boucherville was in trouble. As the blackout stretched from hours into days, the thin veneer of modern comfort began to peel away. The cold inside the houses began to match the cold outside. This is the story of that desperate week. It is the story of a paralyzed power grid and a community running out of time. But mostly, it is the story of an engineering miracle. It's the story of how a group of people looked at a massive diesel locomotive, a machine built to haul coal and steel across the continent, and decided to turn it into a lifeline. Part 1. When the silence set in. To really understand why this solution was so radical, you have to understand the fear that was gripping Boucherville. Winter in Quebec is not something you trifle with. It is an apex predator. The infrastructure is built to handle snow, feet of it, yards of it. But it wasn't built for ice. The weather system that parked itself over the St. Lawrence River Valley was unique. It dumped freezing rain for more than 80 hours. The physical weight of that ice was catastrophic. Imagine a single power line. Now, coated in 4 inches of solid ice, that line now weighs hundreds of pounds more than it should. Now, you multiply that by thousands of miles. The grid didn't just fail, it was physically crushed. Over 1,000 transmission towers and 30,000 wooden poles simply snapped. For the residents of Boucherville, the reality was terrifyingly simple. The power was gone, and looking at the twisted metal in the streets, they knew it wasn't coming back anytime soon. Then came the temperature drop. Buildings in Canada are well insulated, but they can only hold heat for so long. By day 3, the residual warmth was gone. The air inside homes and municipal buildings turned frigid. You could see your breath in your living room. The indoor temperature began to slide dangerously close to the freezing mark. This wasn't just uncomfortable. For the elderly, for infants, and for people with medical conditions, this was lethal. Hypothermia was a very real, very immediate threat. The city had done what it was supposed to do. They had opened emergency shelters. The main community center and city hall became sanctuaries for the vulnerable. People flocked there, wrapped in blankets, looking for safety. But here is the catch. Those sanctuaries were running on borrowed time. Standard emergency planning relies on backup diesel generators. You've seen them. They hum away behind hospitals and schools. But those machines are designed for sprints, not marathons. They are meant to bridge the gap for a few hours, maybe a day. As the crisis dragged into a week, the fuel supplies dwindled. But worse than that, the machines themselves began to give up. They were never designed to heat massive municipal buildings 24/7 in extreme cold. They started to sputter. They overheated. They failed. The mayor and city officials looked at the map. The roads were sheets of black ice. Evacuating thousands of people was logistically impossible and too dangerous to attempt. They were an island of cold. They didn't need a few portable generators. They needed a power plant, and they needed it right now. Part 2. The Lightbulb moment, necessity, as they say, is the mother of invention. But in a crisis, desperation is the mother of innovation. The solution didn't come from a textbook. It came from lateral thinking. It came from looking at the resources available and asking a crazy question. Someone, somewhere in the chain of command between the city and Canadian National Railways, known as CN, had an epiphany. They realized that just down the tracks, sitting idle, so were some of the most powerful mobile generators on Earth. We just usually call them trains. To the average person, a train engine is just a vehicle that pulls cars. It's a big truck on rails. But that's not actually how they work. Almost all modern trains are diesel-electric locomotives. Here is the breakdown, and it's fascinating. Inside that massive steel shell, there is a gigantic diesel engine, the prime mover. But that engine doesn't turn the wheels. There is no drive shaft connecting the engine to the axles like in your car. Instead, that massive diesel engine spins a generator, a main alternator. That alternator produces a colossal amount of electricity. Under normal circumstances, that electricity is fed into electric motors sitting on the wheels, called traction motors. That is what moves the train. So, the engineers realized something simple but profound. If they could unplug the wheels, if they could disconnect those traction motors and divert that massive electrical output to a cable, they wouldn't have a train anymore. They would have a rolling power plant. The candidate for this mission was the MLW M420. This wasn't a shiny new toy, it was a workhorse. Rated at about 2,000 horsepower, this machine was a beast. In electrical terms, the engineers calculated it could pump out roughly 375 kilowatts of power. But power alone wasn't enough. It had to be the right kind of power. The North American power grid beats like a heart at a very specific rhythm, 60 hertz. If you pump electricity into a building at 50 hertz or 70 hertz, you will blow out every computer, light bulb, and heating system in the place. So the M420 was perfect because its governor, the computer that controls the engine speed, could be tricked. The engineers could lock the engine's RPM at the exact speed needed to produce that perfect 60 hertz frequency. On paper, it was the perfect plan. In reality, it was a logistical nightmare. Part 3. The risk and the gamble. You might think that in an emergency, everyone would just say yes immediately. But the corporate world doesn't work that way, even in an ice storm. Before a single bolt could be turned, this operation had to be approved. And for CN Railways, this was a massive ask. They are a freight company. They move lumber and grain. They are not a utility provider. Imagine the conversation in the boardroom. The lawyers were likely terrified. What if the surge blows out the wiring in City Hall? What if the locomotive catches fire? Who pays for the damages? There was no handbook for this. There was no standard operating procedure for converting a locomotive into a municipal power station. And then, there was the technical nightmare known as backfeed. This was the scenario that kept the engineers awake at night. If they hooked the train up to the building, and the building wasn't perfectly isolated from the main power grid outside, electricity could leak out. It would flow backward, out of the building and into those downed power lines lying on the snowy streets. Somewhere, miles away, a Hydro-Quebec lineman could be working on a wire he thinks is dead. If the train pushed power into that line, it would kill him instantly. The isolation had to be absolute. One mistake, and the rescue mission becomes a tragedy. But here is where the human element shines through. Despite the liability, despite the risks, the leadership at CN looked at the situation. They saw a community freezing to death. They listened to the engineers, the risk managers, and the lawyers. And then they made the only decision that mattered. They gave the green light. The mandate was simple. Do it, but do it safely. Part 4. The Great Lift. Now, the problem moved from the boardroom to the frozen street. They had a train, they had a building, but trains run on tracks, and City Hall was not on the rail line. They couldn't just drive the train there. A locomotive like the MLW M420 weighs over 100 tons. If you tried to drive it on a normal road, its steel wheels would slice through the asphalt like a knife through butter, and the sheer weight would crush the sewer pipes and water mains underground. They had to fly it. A specialized heavy-lift crane was dispatched to the rail line nearest the town center. The scene must have been surreal. The town was silent, encased in ice, and suddenly the roar of heavy machinery pierced the air. Crowds of bundled-up locals watched as the crane rigged the massive locomotive. Slowly, inch by inch, the iron giant was lifted into the air, 100 tons of steel dangling against the gray sky. They lowered it onto the asphalt of a main street. But they had to be surgical about it. They likely had to lay down protective mats or track panels to distribute the weight, though the records simply say it was placed on the street. Then began the slow, careful journey. They had to position this behemoth right next to City Hall. It was a game of inches, maneuvering a machine the size of a house without clipping traffic lights or sliding on the icy ground. Interestingly, they actually had a second locomotive on standby. They wanted a backup for the backup, but the engineers ran the numbers on the local overpasses and bridges. They shook their heads. The bridges couldn't take the weight of 2 engines, so the second train was left behind. The M420 was on its own. Part 5. The heartbeat returns. The locomotive was parked in the shadow of City Hall. It looked out of place, a piece of heavy industrial rail equipment sitting on a suburban street. Now came the moment of truth. The connection. CN engineers and municipal electricians worked side by side in the freezing cold. They ran heavy-gauge cables from the locomotive's generator output. They bypassed the traction motors entirely. Essentially, they performed open-heart surgery on the train. They ran those cables into the main distribution panel of the municipal complex. Then came the most critical step, throwing the transfer switch. Click. That sound severed the building from the outside world. The grid was cut off. The danger of backfeed was gone. The building was now an island, waiting for its new power source. The operator climbed into the cab of the M420. He started the prime mover. The massive diesel engine coughed to life, settling into a deep, rhythmic rumble. The governor locked the RPMs in. The frequency stabilized at 60 hertz. The contactors closed. Inside the shelter, people held their breath. First, the lights flickered. Then, they held steady. The darkness that had lived in the hallways for days was pushed back. Then, a sound even better than the engine started up, the hum of the HVAC units. The fans kicked on. Warm air began to circulate through the vents. Outside, the locomotive roared, burning diesel to create heat. Inside, the fear began to melt away. Mothers unwrapped their children from layers of blankets. The seniors could finally relax. The sound of that engine running on the street wasn't noise pollution. It was a lullaby. It was the sound of safety. For the rest of the crisis, the M420 sat there, chugging away, keeping the heart of Boucherville beating while the rest of the province remained in the dark. Part 6. The cost of heroism. Eventually, the thaw came. Hydro-Quebec crews, working around the clock in heroic conditions of their own, finally repaired the pylons. The provincial grid was re-energized. The lights in Boucherville stayed on, this time powered by the great hydroelectric dams of the north, rather than the diesel engine parked on the curb. The cables were disconnected. The locomotive shut down. Silence returned to the street. The operation was a massive success. No one froze. No one died in the shelter. But for the locomotive itself, the ordeal wasn't quite over. You see, machines are like living things. They like routine. A freight locomotive is designed to run, to pull, to vary its load, to feel the wind through its radiators. It is not designed to sit stationary at a high RPM for days on end. When CN mechanical teams got the M420 back to the shop, they had to perform a full autopsy. They checked the wheels. And even moving it that short distance on the pavement could have scarred the precision-machined steel. A flat spot on a train wheel is a disaster at 60 miles per hour. They checked the internals. The stationary operation meant the cooling system hadn't worked efficiently. Without the wind rushing past, hot spots could have developed deep inside the alternator windings or the bearings. They checked the fluids. The oil and filters were likely cooked, degraded by the unusual stress of the constant load. The locomotive had taken a beating to save the town, but, like a good soldier, it was patched up, serviced, and eventually lowered back onto the rails. It went back to its anonymous life of hauling freight, indistinguishable from any other train on the line. Part 7. What we learned. The Boucherville locomotive incident of 1998 is often forgotten. It's a footnote in the larger story of the ice storm. But if you dig into the fields of disaster management and engineering, it is a legend. It teaches us something profound about resilience. We often think resilience means having more backups, more batteries, more generators, more budget. But this story proves that true resilience is about adaptability. It's about looking at the world around you when the plan fails and asking, what else can this do? It highlighted the concept of resourcefulness over resources. Boucherville didn't have the resources to buy a megawatt generator. They couldn't order one from Amazon, but they were resourceful enough to see that a train was a generator. It also taught us about the power of handshake agreements. In a modern world paralyzed by bureaucracy and liability forms, this operation worked because people picked up the phone. The city and the railway trusted each other. They cut through the red tape because lives were at stake. That cross-sector collaboration, government and private industry working as one, is the gold standard for crisis management. And finally, it proved that safety and speed can coexist. In the chaos of the storm, amidst ice and high voltage, nobody got hurt. The protocols worked. Conclusion. The legacy today, if you visit Boucherville, you won't see a statue of the MLW M420. Life has returned to normal. The trees have grown back. The pylons have been reinforced. But the image remains powerful. Picture it one last time. A massive iron train sitting quietly on a suburban street, surrounded by a world of shattered glass and ice, a cable running from its heart into a building, keeping the darkness at bay. It serves as a reminder that our systems are fragile. The grid can break, the weather can overwhelm us. But human ingenuity? That is the one thing that doesn't freeze. The lesson of the Boucherville train is simple. When the lights go out, look for the power in the unexpected places. Sometimes the thing that saves you is the thing you've been watching roll by on the tracks every single day.